surface.
Mm-hmm. Yeah, it does.
So you are technically right when you say level is horizontal, but it also means that, there's another definition that goes along with it.
Yeah, but we weren't talking about the level. We were talking about the horizon being parallel.
We're talking about the shape of the Earth.
We were talking about density.
Yeah, we're talking about the shape of the Earth, which is curved.
No, we were talking about a density gradient in a fish tank.
Oh, okay. Well, that's fair enough. Right. But, I mean, there is a definition that says, it confirms the curvature of the liquid parts of Earth's surface.
Yeah.
Just saying.
Yeah. And if that curvature is 0, then it would conform to that, wouldn't it?
But it is curved.
Horizontal.
It's an oblate spheroid, mate. It's an oblate spheroid, mate.
A horizontal.
3959 radius.
A horizontal isn't curved, is it? That's a straight line.
If you want to get technical with that, then I will give you that. But Earth is an oblate spheroid. Okay.
Will you give us the fact that a horizontal is parallel to the plane of the horizon as well? Or are you going to be like?
But down here in Australia, where I am on Australia would be a different. It's a tangent. It's not. Wherever you are located, if you were to look at where I live in Australia, I'm basically poking out at a different angle to you in England.
I've never been to Australia, so can I just get you to check?
Maybe you should try coming to Australia and checking out how the sun moves here, and then tell me if it's still flat.
Are your horizontals in Australia parallel to the horizon?
My shelves are parallel to the floor. Yes, they are level to the floor.
No,
the sun doesn't move the sun, Bev. The sun doesn't move the way it should if Earth were flat here. It's impossible.
You said it best though, Cypher, a second ago when you said it's more like a tangent line, because it is more like a tangent line that's above the surface, on the surface, but the horizontals are basically
kosher. A tangent has to touch the surface of a sphere.
That's why he said like.
So you can't have above.
Yeah, that's why he said almost like a tangent line. That's why I said like a tangent line, except for the fact that it's above the surface.
You mean it's just a straight line then? Yeah.
Well, Bev, check out the photo I've just posted. I took that photo. Bev,
I've just horizontal.
Bev, look at the photo I've just posted in the chat. Have a look at that photo and tell me what the problem is with where that sun is, please. That's the sun. I took that photo last Thursday.
It's in the sky.
It is in the sky. Right. Can you see the direction of where it says southwest?
Brilliant.
Yeah, it's setting to the southwest. It sets to the left of me when I'm looking at it.
Okay.
If I'm looking west, it's setting to the left of me. Now, it shouldn't be doing that if Earth were in fact flat and the sun and moon move around the flat Earth equidistant from each other.
We were I've not suggested anywhere in this conversation that the Earth is flat. We were talking about basic density gradient in a fish tank.
Well,
and we were
now we're talking about Earth being flat. Well, now we're talking about Earth being flat, aren't we?
The reference range that we were talking about, right?
Horizontal, bro.
Yeah, horizontal. Is that in Australia? Because I've never been to Australia. Are your horizontals parallel with the plane of the horizon in Australia?
With the floor? Sure.
No, the horizon. You don't think the horizon is the floor, do you?
No, but I am on someone's horizon. You're on someone's horizson. If I see a house 5 kilometers away from me and that house is dipping below the horizon,
my house on a sofa, that is definitely not anybody's horizon.
Yeah, you're on someone's horizon. If I were to go out to see from where I live, Bev, stop. If I were to go out to sea from where I live, my house is then going to be on the horizon when I'm out at sea. It's going to dip below the horizon as I go further away from it too. Now, why is that?
No.
Why do things disappear below the horizon? If I were to then come back
horizontals be parallel to it?
Rise up out of the ground, isn't it? And I'll be back in my house. You're always on someone's horizon, no matter where you are.
Right. Is it parallel to the plane of the horizon? Horizontal.
Horizontal horizon.
Parallel, how do you mean? To the what? The house?
No. Listen again. I'll really simply, right? Is the horizontals that you have in Australia, are they parallel to the horizon that you have in Australia.
They're parallel to everyone's horizon, Bev, no matter where you are.
Not the top of the dome.
Thank you.
I was doing some quick numbers with the thing we were talking about with the fish tank. And if the fish tank was 2 feet wide, then the amount of curvature you would expect, and say like the sagitta, for instance, the sagitta in the center.
Wait. So you say you'd expect what? You're assuming some sort of curvature that I'd expect, not me.
Don't ask me ridiculous sea lion questions, okay?
No, Kosho, you just said you'd expect. I don't expect any curve.
To everybody else in the room who's not
Zero.
doing, so please stop doing that. But yeah, so a fish tank that's 2 feet wide, 2 feet from left to right, the amount of curvature that you'd expect, and on the way in which we understand the Earth to be, with some density column in there, the sagitta in those lines would be about 8 nanometers, which is smaller than any perceivable light. And
would that be at the center, Kosho?
It'd be the height.
Would you imagine that it being in the center?
Straight line.
At the center.
I heard that fish tank. Yeah, that's what the sagitta is.
Right, so not like a drop from one end, depending on which side you're at. It's definitely in the center.
The drop from one end to the next would be.
I got a better idea for you.
It would depend on which side of the fish tank you're stood at, right?
No, for his building thing.
The chord and the arc length, the distance between them at the center is 8 nanometers.
At the center.
Kosho.
Okay, so you definitely the hump, Kosho. Kosho goes for Bislin hump.
Would be.
Well, I got something to help us.
Not be perceivable.
Right, so if you could scale that up bigger, what sort of scale would you have in order for you to be able to measure it?
He could put.
You imagine. When you lot that imagine curvature, when you imagine that curvature, how big would you have to make the scale of that thing for you to be able to measure that imagined curvature, Kosho? Come on.
You'd simply want a sagitta that would be a value that you could at least perceive.
No, Kosho, I got you.
Imagine it's immeasurable.
We've been given some numbers. Oh, it's Becky. Hey, Becky. I'll show you that proof at some point. But I mean, here you go. Look at these numbers here in the chat. Yeah, I seen you joined. I'll come over and show you that proof. See these numbers here, Kosho. Which one of those numbers do you imagine you could measure?
All of them.
All of them.
Yeah, millimeters. Yeah, if you have a ruler, you can measure any of those.
Fantastic. They are your imagined curvatures, right?
They look like fairly, numbers that are all on a ruler. Yeah.
Yeah.
All those numbers are on.
You read it at the top. Read it at the top. It's 16 individual 100 meters, unsighted, no dark sharks involved in this. Water level, calculated mind measurement drop of each individual level from the start position. It's sort of like Sly Sparkane's bending water level experiment.
But you didn't know who Sly was.
I said sort of like. I mean, these are the numbers that we've been given by.
And I said I thought you didn't know who Sly was from what you were saying last night.
He's a nameless, faceless internet potato that has a bending water level experiment.
That's fine. So I put in a number for 1 millimeter, and for you to perceive, or for you to expect there to be a 1 millimeter sagitta in the center, it would need to be 225 meters. So what number did I say before? I said 24. No, so actually before. Hold on. I said inches. No, that was right. That was right. It was 24 inches before.
Right, say that again.
Of the roof.
You say that again, Kosho. At 225 meters, 1 millimeter.
No, and it would need to be 8,800 inches. So yeah, 225 meters.
What, Kosho? Please don't get your imperial measurements mixed up with metric. Are we working in inches or meters? Right, please.
I just gave you both. That should be sufficient.
Okay, well, can you see that thing there with all of the numbers? And I know people are probably better at numbers than you are. off the top of your head, but they've wrote them down for us. We don't need to bother doing it. People have given you the numbers now.
People have also measured the curvature of Earth many times over.
These are, it's been claimed to be measured.
No, they have done it.
No,
many times over.
They've run whenever they've been asked to provide
evidence. Your denial of it doesn't make the fact that they've done it any less true.
Well, there's no fish tanks that are 8,800 inches across. There's no fish tanks.
But no, these are like 100-meter water levels. And you line them all up next to each other, one, and then the next one, and then the next one, and then
see how you go.
Pardon?
Right. And how do you then measure the millimeters difference in the sagitta?
How do you measure?
How would you measure the sagitta and those water and the 100-meter sagitta?
I don't know. By the way, listen,
I've
tried to explain this many times to you, right? I'll explain it to Becky.
Listen, Bev, show me your chalk line of your fucking. Your fucking water towers down a row. Show me your fucking chalk line. What's up?
It's pretty obvious, Becky, right? We're not going to.
Well, how do you?
We can't do it here. This
answer
is why
his
we
question, man. I'm thirsty, motherfucker. Answer Kosho's question, please.
We'll
please,
let him
please,
finish his point. Can we? Before we all break out in outrageous, attacks.
I gotta go. But I'm saying, please don't skip this one question, Bev. Please.
Go on, Kosho. Come on. Give us your question. I'm sure it's going to be a brilliant one. What was it again?
I said, how do you expect to measure? For instance, I don't know what numbers those represent. You said drop. I gave you the sagitta, so I'll give you the sagitta again.
Yeah. You know how your model works, don't you?
For that same distance, as I told you, 225 meters, the hump in the middle from the chord, the distance between the chord and the arc is 1 millimeter. So if you're 225 meters from the end,
the chord and the arc. What are you talking about? The chord and the arc, 1 millimeter.
I was assuming I was talking to a learned man who knows what a chord and an arc are. Yeah,
well, that's not what we're doing here. Right. That's what Brandon was doing the other day. That's what Rumpus and all of them had Brandon doing. Absolutely fucking ridiculous. Don't even try it. We're talking about the sagitta. Why did you change from the chord?
That is what we're talking about.
To the sagitta.
Because the sagitta is the distance from the chord to the arc. That's what the sagitta is.
Yes, okay. Right. Then numbers, I'll put them again.
We all live in a 3D space.
There, right. Those numbers for the baller local curve calculations. Right. Can you see those numbers?
Yeah, so I'll ask the question again, though, now that you know that we're talking about the exact same thing that we've been talking about.
Yep.
How would you perceive, after 225 meters from one water level to the next, how would you perceive this millimeter in the center?
Kosho, once again, can you see the numbers?
I do.
Right. Now, they are 16 individual, 100 meters unsighted. Now, can you see the number 2 on that page?
No.
Right. That's 200 meters.
I don't see it.
Oh. Baller, local, curve, calculations. Can you see 1, 2, 3, 4, 5? They're at the top. They're the ones that Ruhif gave us. They were his starter numbers. He got one of them wrong. But never mind.
There's some yellow print. I can't read
it. Yeah. That's it. That's
I can't read it.
The one we know. It says 3.1 millimeters. Now, you said 225 sagitta, 1 millimeter.
That's right. Yeah.
So maybe DP might need to fit in. There is a little bit of a space in there, DP. Kosho says that for 225 millimeters, do you want to check them numbers? Kosho.
Their numbers? No, I can't read
that. No, do you want to check your number that you've give us? 1 millimeter for 225 meters.
I'm fairly confident about it.
Check with your model. Do you want just check? I don't want to,
There's no need. I'm fairly confident. Yeah.
So you're going with that then, right? 1 millimeter sagitta.
I've almost already said it 3 times now.
Brilliant. Are you getting that, DP? I hope you are. 225 millimeters sagitta of 1 millimeter. Ruhif had that down as 100 meters. But anyway, forget about that. The numbers on the page, I've even had maths people come and tell me how this works. The drop is the same as the hump over half the distance. Because obviously the water can't drop away. Like, there's no way the water level drops from horizontal, is there?
Sure it can. Gravity helps hold it to the planet.
Right, so you're holding a
Gravity
water
does
level.
hold it to the planet.
You're holding a water level 100 meters long, right? Well, you see, you can only hold one end of it. Let's say you just put it on 2 posts, right? You stabilize them. You fill it up with water. Now, that water that in that tube will reach an even altitude, won't it? It will equal out to be even.
But I do think that.
Kosho, please, no, Kosho, please don't interrupt. We've got to get this sorted first. Just so we, but somebody else asked the question. You're now interrupting them, aren't you?
That's the question.
So the water level, right? We're just establishing it can't drop at either end because it makes an even altitude. You will agree with that, right?
Right.
Yep.
The question I was just answering, which is, I don't agree with that. I think that I think if we talk about the elevation of each of them, you'd be saying that in their local positions. But if you
they'd have to be touching the floor to be elevation. It's an altitude. It's above the floor.
If you compared the 2 ends in the middle, and you made a straight line from one end to the next end, and you looked at the middle one,
the 2 ends in the middle,
the middle water level would be higher than that.
Really confused.
No, Kosho, they're not.
So, there would be. Right. Oh no.
After 205 meters, it'd be 1 millimeter higher.
I'll leave you two to do this. I mean, Becky, anytime you're ready, if you've got a bit of spare time, I'll take you through.
No worries. Thanks, Bev.
Do you have an opinion, Becky? Like, when you fill a tube of water up and it's even, right?
Yes.
Right,
absolutely.
Okay. So
level
there's
is
no drop.
so I just want to say level is horizontal and vertical is plumb.
Thank you. So it sounds like you've got a good grasp of reality.
Yes.
Yeah, it should be easy to take you through this. I mean, you should get this, no problem. Right, guys. So considering it's even, then you can't measure a drop at the other end because, I mean, that's obviously not there. Well, despite what some people decide to think. I mean, Jesse Kozlowski said it drops from the horizontal, but I mean, it's ridiculous. That's probably why he's gone missing, because he can't substantiate the claims he's made. He said, oh, yes, it's measurable too. Well, absolutely stupid. Right. So anyway, Kosho, so these numbers are drop numbers, which obviously can't be true. But the sagittar is what would be measurable, the hump. That's why you have such a confusion between drop and hump. It's like a model paradox that you have.
Just describing the sagittar.
Okay, right. Well, the sagittar is the half distance, isn't it?
Right.
Of this.
Yeah, where that distance from the chord to the half distance of the arc. That's right. It's that exact distance.
Okay, so at let's say 400 meters, if we had a 400 meter tube, yeah, according to that, there should be a 12.6 millimeter drop at 400 meters, but that's obviously not there, is it? Can't be. So what we have to do is we have to take the midpoint, which is wrote down here as a drop, but because we're leveling that total distance off, the half distance would be the sagittar. It's a quarter distance function because it's a quadratic equation that you have for your mind maths, right? For when you perceive a curvature, it's a straight line, but you do some mathematical calculation, and that is equivalent to the 8 inches per mile squared, right? That calculation that you've been given. Well, the half distance of a 400 meter water level would be 200 meters, and that says 3.1. But you said 1 mil? Why is that?
Oh, that's because you're describing the drop, as you said, which is not the same thing as a sagittal.
No, like I said, a half distance, it's a quarter function of your total perceived ridiculous drop that isn't there. So you have to take the hump because that's measurable, right? You would agree that you can definitely measure that sagittal, right? If it was there, of course.
I didn't say you could definitely measure it. I'm saying that you would have to have tools precise enough to measure it.
That's what I was saying. Like, what do you measure distances of around 1 or 2, 3 millimeters? What would you measure that with?
We're talking about something that would be in the center. The comparison between the straight line.
I'll try this one again with Becky, because Becky definitely lives in reality.
I'm trying to answer the question, Bev.
Okay, go on.
Why do you not do that? If you're trying to compare the chord line to an arc line, you would have to first define those lines, which means you would have to have a straight line from one water level to the other to be able to measure that millimeter. So that's where the limitation is.
Okay. So Becky, if you wanted to measure something, let's say 3, 4, 5, maybe up to 20 millimeters, what would you use?
I would use a ruler.
Brilliant. You are way above these guys, aren't you? You know, this living in reality
Just kidding.
gives you a foot above Kosho and people like that. It seems, right, Kosho?
Dear me, Kosho.
She can
measure
distances with a ruler.
You know, he's making a good argument. Just kidding.
Becky, think about what he just asked. He asked you how you would measure something. Now, Bev, tell her what you're going to be measuring, Bev, and how you're going to have these two lines in front of you to be able to put a ruler up to it.
Just a pencil mark.
You're measuring the distance between a chord and an arc, in the middle of these two water levels. So you'd have to define that arc. You have to define that chord to make that measurement. That's the difficult part. Measuring 20 millimeters is not difficult.
It's a piece of piss, Kosho. Absolutely simple, but I don't think you'll get it. I really don't.
Find how you make that straight line then.
Pardon?
Have you heard of vernier calipers? Do you know what a vernier scale is? Yeah, I would use the vernier scale because I can see shit down to 0.01 millimeters. That's a thousandth of a mil. I can see that with my own eye. Yeah, wow, I know when something is a thousandth of a mil out. Yeah.
Brilliant.
I'm an engineer.
You could do it over 100 meters. Well done.
Yeah, wow, you can do it with a laser, vernier calipers, micrometer, depth gauge, vernier depth gauge. You can do it with all sorts, and they're measured down to 0.01 thousandth of a millimeter. Ooh. In fact, they measure down to 0.000. But yeah, they'll give you a 0.01 thousandth of a mil. That's a tenth of a millimeter, mate. That's even smaller than half a mil.
Brilliant. I'm glad you can measure to that sort of. That makes it even cheaper, you know, if you can get somebody like you involved.
Well, vernier calipers are only like £5 on eBay. You can buy them like with a dial on them, or you can buy the electronic ones, and they'll give you the reading electronically or on a dial. I would get the electronic ones though, because the dial ones are a bit hard to read. The one with the vernier scale, because vernier scales are just slightly out. You see, they're a bit weird. You know what I mean? You have one set of lines, and then the other set of lines don't match up with it. They're slightly out, if you get me. That's the nature of a vernier scale. And there are millions of different types of vernier scales.
If you come over, I'll be able to show you how you can actually measure to such levels, right? Yeah. Becky's right, though, with a ruler. I mean, that's the way I'd use a ruler. Much more
Man, like I have metal rules.
Everyday person sort of thing, right?
Yeah, I have metal engineers rules. I have a 12-inch metal engineers rule and a 6-inch one, and they both have
I've got them
millimeters on them, and they both have like conversion skills on the back, which are pretty handy, you know. So if you've got something that's half a mil, or say a quarter of an inch, then it'll give you the skill to work it out on the back to millimeters. It's quite useful, you know.
Yeah, I've got loads of different rulers as well. I've got a 5-meter ruler.
They're all right. If you want a tape measure, mate, you want a 25-foot tape measure. That'll measure anything.
I mean, staff, like actual.
Oh, a staff one. Yeah. Like like the old yardstick. Yeah, I know what you mean.
Yeah. Like so, would you be interested in trying to measure? Would you go for the drop or the hump if you were measuring?
Thing is that Rob often measured the drop on the canal back in the day, but he had the telescope too low to the boat, and somebody went back a couple of 100 years later and redid it and raised the telescope about 3 or 4 fucking meters in the air on a big tripod, right? Then he did it and he took the readings and he found out, that it did have curvature after all. I wonder why. Because he measured it too low. So he got all his measurements wrong. Never mind.
Okay, so you were there for that one. 3 or 4 meters high on a telescope.
Yeah, well, you've got to read history and read into history and see who did it. I mean, a woman revived fucking flat earth.
Was that Robotham or somebody else that did that?
Probably fucking Claire Summit. Mrs. Claire Summit. She was like a big reviver of the flat earth. Not so long back, actually.
Rumpus. Is that years ago. Similar to Rumpus's then? But Rumpus is using a 20-odd foot stick at the other end.
Well, you can use a 20-foot stick, yeah.
Like dark shark, dark shark at one end, and then looking the other way. I don't know. I think he said he might be doing reciprocal.
Yeah, but I mean, they didn't have theodolites back in the day. You know what I mean?
Satellites.
What do you mean back
in the day? It's quite a recent invention. Is the bloody theodolite? We've only just invented that bugger. What do you mean? I mean, the best they could do was a telescope.
Oh, right. So no horizontal measurement or anything.
No fantastic fucking super accurate measurements, mate. It was probably some poor cunt freezing his tits off.
Can't rely on that, then, can we?
Stood in the middle of the canal with a fucking stick in his hand. He was probably freezing his tits off doing it, but Roboth, he'd have been sat nice and dry in a fucking boat. You know what I mean? The clever cunt.
You're a good representative of this.
Those definitely existed back then, and he wasn't trying to make a precise measurement anyhow. He was trying to just make sure that the 3 sticks, one would be higher when you're referencing the two. Yeah. Just like we said, the 2 ends will have the one in the center is going to have a sagitta that is greater than 0, meaning that it's curved.
Yeah, and the next one will be reading a slight drop in the fucking curvature. Yeah, and then the one after that, I'll show you the fucking sag, and then the other one will show you the fucking drop. It just carries on like that, yeah. Depending on how much distance there is between you and the next line, Yeah,
this is why I have to ask and get confirmation of people, because so many people say so many different things. The only thing I can go with is what I can prove for myself.
There you go. Then what are you asking everybody else for?
I'm just asking everybody else's opinion, right? Of what
seeing if they've got a different angle on it, a different fucking idea that might reinforce yours a little bit.
Yeah, we can still learn different ways off each other, can't we?
Well, we can, yeah, but there is only one way of fucking doing it,
Measuring,
yeah. Measure twice, cut once, as you do.
Well, that's what they did, didn't they?
That's what you've got to remember. Measure twice, cut once. If you remember that all your life, you'll never cut anything wrong.
What happens if you cut it and it's too small? So
you can add a little bit on.
Measure it properly then.
Cut it again and then it fits, right?
Well, no.
And you've wasted material.
Cut it off and it's too big.
Cut it and it's too small, and then you cut it again. It's.
No, it doesn't.
Twice.
How? If you cut it, I don't get that.
Material, doing it wrong.
Putting more off. The thing is, you can add back to wood. That's pretty easy fucking material to add back to, but steel's another fucking thing, you know what I mean? When you've cut a bit of steel off, you've literally fucked it, you know what I mean? It's hard to weld a bit of steel back on, but wood, you can scarf it, you can fucking cut that a bit off, you can stick a new bit,
you do it with all sorts.
It's material to work with.
Cut it off and then find out that it's too small, so you cut a bit more off, and then it fits.
A bit more on you
all the time.
Idiot. No, it don't work all the time. You're a nugget. If you think that's works, mate, everything that you build is going to be like 2 inches too fucking short. You know what I mean? I bet you don't even add on the bit. I bet you don't even add on the or take off the bit that you're adding on, do you?
Yeah, I'm a joiner.
And you don't take off the bit that you're adding on.
You don't take off the bit that you're adding on. What do you mean?
Yeah,
I mean, what I said was when you cut something and it's too small, and then you cut a bit more off and it fits.
How can it be too small? You fucking nugget.
Oh.
It's got to be too big, hasn't it? If you're cutting a bit off and it doesn't fit, it's too big, you nugget. Not too small.
Mm.
So you cut a bit more off and it fits, yeah, because it's the right size then.
Yeah. Once you've cut a bit more off.
It's going to make it too small, you nugget.
It was too small in the beginning, the bit that you cut off.
See a fucking doctor. I already know what you're on about.
Do you?
Yeah.
Yeah. Cutting holes?
Mate, the more
Cutting holes for a pipe?
Yeah, the
oh,
more
shit, I've cut it off and it's too small. I best cut a bit more off. Hey, the pipe fits. Boom!
So you're talking about holes. All right. So the more you take away from it, the bigger it gets. How fucking clever of you.
Yeah. You just got to think of it from a different angle, I guess. We can all learn from each other, can't we?
Yeah, you're a fucking wind-up merchant.
So
twat.
when you're measuring, when you were measuring, can you see the numbers? I'll post it again. Well,
I can't see any numbers now. You're fucking knackered it. Now I've got fucking big holes and little holes. Fucking go away, you annoying fucker. I'm making my joint. Go away.
You will definitely be using that one though, won't you?
Well, yeah. Well, let's all use an hole to measure with, you know.
Not really a line or no, but you know, we talked about the cord and the.
You did.
Yeah, and well, no, you did as well. You just didn't know what the terms meant for some reason. But because we say the curve.
Talking about a water level. I mean, it's not a cord. Right. I mean, how could it be a cord?
Well, the two ends, the line created by the two ends would be the cord between them.
What?
Yeah. And the shape made by all of them, if you took each of the position of the tops of them and drew a line, it would make an arc. So that's how you would compare the two. I've made a picture.
Right,
so
that is where you would measure. You say in the center.
That would be one way. That would be the way that the Bedford level test was done.
Brilliant. And Tao says he can measure something down to nanometers. Was it Tao? I mean, like 0.000
thousandths of a millimeter.
Right. Have a calculation. Have a calculation, Kosho, of the sagittar in a 100 meter.
Tao, could you make that from 100 meters away?
Could I make it?
Could you measure that? Could you measure that distance, the millimeter or sub-millimeter, whatever? With
the theodolite, yeah, I wouldn't be able to do it with any calipers, but I could measure it like if I had a big enough vernier caliper, I guess.
Why do you need a theodolite?
Theodolite, because they're just easier.
I thought you had calipers and some extra fancy measuring things. Becky's got a ruler. I'll go with a ruler.
You can't use a ruler.
Well, actually, you don't really need the numbers. You'd just be able to look at a pencil mark, I think.
But you can't do that from 100 meters away. So
no, you can't mark a pencil on the mark at the end of the water level from
that's
100 meters away either.
That's why you'd have to make a defined line what the cord is. And
but then a water level is it's a practical tool, Kosho, right? You go to the end where it is that you're using and use it that way, right? You don't.
Yeah, water level
from 100 meters away.
The fucking water level. Using a water level to fucking measure a water level. What the fucking hell are you doing?
Yeah.
You go to the end and you have to reference the other end to make the cord.
Why don't you just use a fucking water that's already
there? You can put a pencil mark, can't you?
Stick a clear pipe in it.
You wouldn't be able to do that from the center.
Stick a clear pipe in it at one end, yeah? Stick a clear pipe into it at the other and measure the fucking height on the clear pipe. There you go. You've already built the water level. The water level's there. You're just using clear pipe. Put it down to the fucking bottom of the fucking water, yeah? And mark up the fucking clear pipe where the water's come to, then go to the other end and do that. You only need 2 equal fucking lengths of clear pipe to do it. There you go. Use your brain.
Rupert, no, they're concentric circles. They share a similar center.
2 equal lengths of clear pipe. stick one in the water to the bottom of the bed of the level. Yeah, go to the end of the fucking level. Stick the clear pipe in that down to the riverbed, yeah? And then make a mark on each one with a pen. Then measure the length of the fucking pipe and there's your drop.
Off you go. On a river, because it's flowing.
You can do it on a river and use clear pipe because the water will come up the clear pipe and be in the clear pipe and you'll be able to mark it off with a pen.
It's a river. It obviously drops. It's
It
water flowing downhill.
It flows at the same fucking height, doesn't it?
It's down. It's in a lower elevation. The water is flowing from a higher elevation to a lower elevation.
I know you want a waterfall. How are you going to use a waterfall? Come on.
No, they're not using waterfall. But
this obfuscation is terrible, Tao.
He's fine. Tao's just fine. But yeah. So what we were discussing. So the limitation that you haven't really overcome yet, but you're saying you can somehow measure this without even knowing.
No, Jesse said you can measure this.
Hold on.
I say it's a straight line. I'll just prove a straight line.
That's fine. You're going to just say it's a straight line. I'm saying to measure this, though, you would need to have those lines defined to be able to take something and measure that distance between them.
Define a straight line.
Anyhow, so this is what the test that a few people in here, including myself, are planning on doing, is defining a straight line and using that straight line to measure, say, the sagitta in a hump like that for like a Bedford level, to do the exact same thing as a Bedford level, except for instead of doing it by sight.
This is different. We're not doing a Bedford level.
No one said your test.
I optics. Yeah.
So people in here is what I said. Is we would be doing a defined straight line and then measuring the sagitta.
Defined straight line. Go on.
Yes.
Start off with that.
Yeah, using accurate positioning.
No, define a straight line, please.
So a defined straight line, not the word
defined.
Line.
Go on then.
A straight line that's defined. Meaning
Yeah,
that
go on.
It's straight without needing to make any assumptions.
Straight without needing to make any assumptions.
That you're confirmed that this is a straight line. That's what I'm talking about.
Right, well, so what is a straight line to you, Kosho? Because yesterday we had all sorts of silly things. It was a circle yesterday. Do you think a circle can be a straight line?
Fantastic, man. I don't know why you're obfuscating when you just were complaining about it, right?
No, you're talking about defining a straight line, and then you seem unable to. Whereas yesterday,
you don't even know what I mean when I say define.
Kosho,
I'm talking about defining the word.
Defined a straight line as a circle.
That's fantastic. No one's talking about the word. When I say define a straight line, I'm talking about producing a straight line, confirming that the line that is made is straight. That's what I'm saying to you.
But what do you mean by straight? Do you mean straight or do you mean curved, like a circle? What is your definition?
Bev,
how do you define
I'm
straight?
Continue with this, Bev. Okay, because you're obfuscating.
I know it's hard work.
No, it's not
grown
hard
men
work.
Struggle with straight lines.
It's not hard work. It's aggravating though when you do that. When there's no need to do that.
Just define it.
So, as I was just saying, we'll have a confirmed straight line, and this will be used to say measure the sagitta. Let's say the straight line.
Can you say? Okay.
Let's say the straight line was.
Is the sagitta a straight line?
Let's say this straight line was both ends of a canal, a 6-mile canal, on the surface of the water.
Straight line?
You would then measure the center of the canal and the distance from that straight line. And you'd be
what straight line? Where's the straight line?
What do you mean? Where is it?
The straight line that you're talking about that you measure something from. Where is that?
Well, you would be using a positioning device like a GPS accurate, centimeter accurate positioning device, which would take
a centimeter accurate. If it's only centimeter accurate, you can't measure a millimeter, can you?
Yeah, but you wouldn't be trying to only measure a millimeter.
That's not very accurate, Kosho. Centimeter accurate is rubbish. Ask how.
You wouldn't be only trying to measure a millimeter. As I said, 6 miles. You could do 10 miles. You could do 50 miles. You wouldn't do 200 meters. You would use it to make the straight line that was 10
miles. Tao says he can measure that at really, really, really accurate numbers.
He's got calipers that he can do that with.
Yeah. Well, so you've said you go to the center and measure it at the center. So he can go to the center and measure it. Surely.
Right, so I can use Tao's calipers then.
So where's the straight line that he's using?
He wasn't using one. That was my point before.
You were defining a straight line.
Yeah, Bev.
To measure from.
Bev, stop doing that. If I'm responding to what you're saying, you don't have to continue to go on.
But you're not responding.
Yeah, as I told you when you asked Becky what she would use.
Talking over him, you fucking twat.
Yeah, you said she would use
a couple of 100 fucking plastic clear pipes.
Yeah, you said
all the same length. It's a lot easier.
You said she would use a ruler, and Tao said he would use a caliper.
Mm-hmm.
And I'm fairly certain anyone can use a tool to measure a distance that they can see, right? But if you're talking about a sagitta, which is going to be the difference from the chord to the arc, which are not defined by anything, you have nothing to measure with a ruler or a caliper from 100 meters away. Okay? That's the limitation. That's why if you define a straight line, you can actually make a measurement of the surface of the water, which is clear to see, and you'll have this defined line.
Okay. Now, please, before we continue, I know you can't define it with words. What method would you use to define a straight line?
Bisect the angle. Pull the cord. And
for a second.
Stick a line through them both. There you go.
Cut out. I didn't hear your question.
What method, because you can't use words, obviously, what method would you use to define the straight line, please?
I told you. A GPS that's accurate within a centimeter. It's accurate within a centimeter precision. You would take a point at one end of the 6 miles and another point at the other end of the 6 miles, and you'd use that points to make an infinitely long straight line.
Well, how would you define that at the center? You've just got 2 points.
Careful, because he's got another trick question there, because what he's saying is where would you put a straight line? Yeah, you can make a straight line.
I'm asking him to define a straight line.
Where would you put it? Yeah.
Jesus Christ.
What would the straight line be on?
Thank you, Tal. I've just told you, Bev.
I want to hear the definition.
That's great. Look it up. I just told you that at one end of the canal, 6 miles, the other end of the canal, 6 miles, there's 2 points, right? These are 2 positions that are going to be defined in an XYZ space, the same way GPS always defines it before they convert it to longitude and latitude. You can use these 2 positions, XYZ coordinates.
They use wait. They used XYZ and convert that into a 2-dimensional.
Bev, can you shut the fuck up until someone's finished talking?
Told you this at least 100 times, Bev. So stop acting like it's news to you. Please, for the love of God. I've had this conversation with you 100 times, man, about how longitude and latitude converts XYZ to spherical coordinates, which is also 3 dimensions. It's not just 2. Longitude and latitude plus the radial distance, which will give you the elevation.
If anybody else can translate what Kosho's saying, I mean, he's not actually saying anything when he's saying that. He doesn't even know what he's saying himself.
Neither are you.
Not really saying anything at all.
You're a fucking lunatic.
I was just trying to get Kosho to define a straight line.
You're just trying to.
We've got 2 points so far.
Line and fucking.
I want to hear it too. What's wrong with that?
Pulling a chemo.
You don't know how a straight line references just 2 points?
I know.
Straight line,
I know.
Straight line
You said you couldn't define it with words before.
No, I said that's not what I mean when I used the word defined. You said, define it. I wasn't talking about defining it in words. I was talking about defining a straight line and being able to use it.
In reality, yeah.
Yes.
Yeah, and you said you just go to each end with a GPS system.
To describe
just do 2 points.
So don't ask me to define words that all of us know the definition to.
So how would you define the straight line that pertains to those 2 end bits in the center for you to be able to measure the sagitta? How would you define that? That's the particular point that I'm talking about. The straight line involving the bit in the middle.
I would take those 2 points and make a line that goes through both of them. Only both of them.
The shortest distance between those 2 points, the 2 extreme points, the shortest path, even distance, without deviation, in a straight line from one point to the other.
Straight line that went through both of them. Yeah.
Mm-hmm.
It's not hard to do.
Yeah,
It's actually one of the easiest things you can possibly do, and it's almost like it doesn't have to be explained to you.
It is Euclidean geometry, the basics. I think we get into definition 5 to get that one. So, I mean, I'm surprised it took you so long. You said you were after defining it, and then you ended up defining it.
And you're asking what a straight line is.
Okay. So how would you, in reality, how would you position that straight line for somewhere for you to measure? How would you do that?
I would use the positioning tool that I just described to position the 2 points. Then I'd have to use some sort of 3D program to visualize a XYZ 3-dimensional grid. I would then define that straight line and all the points on it, not just the 2 points at the end, but every point on it. And I would find the point in the center that was directly beneath that straight line. And by doing that, I'm not directly beneath it. I'm sorry, directly above it. The surface of the water that was directly above it, because it would be the chord in the water.
Okay.
You would then take a line that was perpendicular, or a plane. I'm sorry, that was perpendicular to that line, in only one axis. Okay. I have to be perpendicular to the downward vector. So
one like vertical and horizontal, right?
Yeah, the simple way that I was first brainstorming to do that would be just to use the same meridian. So make that straight line along one meridian, and that way you could just take the middle point distance between those 2 points.
No, you're making the straight line between 2 points.
Yeah, 2 points, but make those 2 points along the same meridian, so that when you're trying to find any of the other points along the straight line, you would just use the meridian to reference them.
You wouldn't use the straight line that you've just made between the other 2 points to reference.
Say what?
Well, you're making a straight line. Why are you trying to reference the straight line, or now all of your other points to a meridian? Why not reference them to the straight line that you're talking about?
Because if you want to look along the surface of the earth, like the surface of the water, I mean,
no, we're after measuring something, aren't we?
No, we've already defined the straight line. So now that you have a straight line defined, if you wanted to measure the sagitta of that straight line, you would need to find the surface of the water that was along that same line, whether it was above or below it. So you need to find a point on that meridian. You would just use the point that was halfway between them.
You would define a point now.
Oh, no, you wouldn't define a point. You'd have to find a point.
Okay.
That was along that straight line.
But you've already found the center point, haven't you?
No, not yet.
Oh.
There's no.
That should be easy. That should just be a measure distance, half of the total length.
Yeah, half of the length. But now you have to find the position of that point, which is why you would do it along the same meridian. Make sure it was along that same straight line. And then you would find that point and measure its distance from the straight line at that same.
So when you get to that point and you can hold a ruler and measure, right?
Well, you wouldn't need to use a ruler. You could,
like Becky says, with a little ruler.
Yeah.
Or maybe, I mean, if you're good enough, you've got Tao in his ultra high position. You could just put him there, and he could measure it even more accurately, couldn't he?
Any of that. Once you have the positions of the straight line and you have the position of this point on the surface, you can compare them in any
any difference. Yeah, any difference would be hump.
That's right. It would be the sagitta right there.
Yeah,
and that would be one way to measure Bedford level style test.
Well done. You just worked through that. We did that really, really well, and we've now sorted out that we're going with the Bislin hump method, and like Jeff says, it's measurable because this is geometry. So yeah, it's definitely measurable. And Becky, I'll show you the method later on. Jeremy, anyone that wants to come over and have a look at it. Yeah. Like, see how well you guys can do. Put your minds together and use Kosho's method that Kosho's just explained there. Genius.
Yeah, that's only one test too. There's
only one of them.
Plenty of tests you can do.
You could do more, couldn't you? At the same time.
Well, you can do drop from horizontal. Create a horizontal
drop from
line.
Horizontal. You could check for drop from horizontal, but that'd be fucking ridiculous, wouldn't it?
No, that would be perfectly feasible.
Would be called a river.
Yeah, but that's not what we're talking about.
Not a water level. A water level has an even altitude with no drop.
We're not talking about water levels or rivers. I'm talking about the Earth. You can take
talking about straight lines.
You can create a horizontal straight line, and then go on both ends. You can go from one side of that position where you made that straight line, and go infinitely far. You can go to 100 different points.
When you say horizontal straight line, you do mean horizontal, not bendizontal, right?
I really don't want to respond to that, Bev.
Do you not?
I really don't. I feel like I said enough words for you to understand what I'm talking about.
Yeah, it's okay.
I don't know why you would ask me if I say a horizontal straight line. You would ask me.
They had horizontal circles going around some sort of a model yesterday. I was hearing quite often. I was just checking it wasn't one of those horizontal.
Anyhow, what you would do is you'd keep going, let's say 10 distances, let's say 5 miles apart each.
10 distances?
Yeah, let's say measure the surface of the Earth at each one of those.
We're putting 5 miles as a unit?
As each one of those distances.
Yeah, we're calling a distance 5 miles.
Jesus. Measure the distance from the surface of the Earth at those distances to the horizontal line you made at the beginning. And you would, at the end of your measurements, compare all those distances, and you would have measured the drop of the Earth from horizontal.
But see, that would make the water drop from horizontal, wouldn't it?
Yeah, anything. The Earth, whatever's on the Earth, yeah.
How do you establish a horizontal again? Oh, you do GPS. Sorry, was that straight line that you made earlier with GPS 2 points? Were they horizontal marks, or was it just a straight line you were doing?
These were horizontal, yeah.
Okay. So the hump is in the middle of horizontal. Call a chord a horizontal, would you?
Sure. It would actually only be horizontal at that midpoint.
But a horizontal is a line, Kosho.
That's right.
Yeah. But you're saying that a horizontal line is only horizontal at the midpoint.
That's right. On a curved surface.
What would you call a horizontal line at the end?
I wouldn't call it a horizontal line.
Oh. So when they say at school, a vertical line goes up and down the page and a horizontal line goes across the page, they meant to say a vertical line just at the point in the middle where they intersect. Just that one point. That point of which there has no parts.
No, there's
nothing in the middle. And the horizontal is also only horizontal where it isn't. Yeah.
About drawing lines on a piece of rectangular paper.
Yeah, you got infinite lines in between the borders, buddy, up and down, both sides. Anyway,
talking about a horizontal.
2 questions. One, why are you pretending like neither you nor Kosho, like I'm saying, why don't you grant you and Kosho the benefit of the doubt that y'all know simple geometry and how to draw 90 degrees? And then 2, what does it matter though? Like whatever the word you want to use, like what's up though?
Because that's geometry, right? They're defined words. Straight and perpendicular are very defined words because they establish vertical and horizontal, 2 right lines intersecting to make 4 right angles. All of those right angles are equal to one another. It's the basic fundamentals of all known geometry and mathematics, to be fair.
Okay. So if this was like just a little random thing, I wouldn't butt into y'all's conversation. But you must know that, the horizontal flat straight line thing, like that's kind of a thing you're known for. That's your stick. You know what I'm saying? So
no, it's reality, right? It's not just mine.
Fine, but I'm saying, dude, you press the thing you're pressing on Coach. So I've witnessed you press it a lot. It's cool. You can recognize